So let me rewrite that. We'll write it over here. I'm going to write, whoops, the sine of 100 degrees is to, what the heck was it? Was it 10? Oh man, my brain's not working real well. It was 15, wasn't it? Is to 15, sorry, is to 15 as the sine of, what was it, 39 degrees, because 39 plus 41, yep, 39 degrees is to C. In a puff of algebra, I get C sine of 100 degrees equals 15 sine of 39 degrees, which implies that C equals 15 sine 39 degrees divided by sine of 100 degrees. And guess what? We're off to the races. So all I got to do is go 15 sine 39. Be careful with your parentheses on this. Again, always check in your mode. Let's make sure, because I can drive myself absolutely insane if I don't have this thing in the right mode. Okay? So apparently we're in the right mode. So where the heck are we? Oh, I shouldn't have done that right in the middle, huh? And I'm going to divide by sine of 100 of 100 degrees. Right? Nothing to it. Let's see what I get. So C equals 9.585. All right, now let's open this thing up and let's scroll back a bit. So C equals 9.585, which tells me that's little c, that's this guy, 9.585. Now, I have had students repeatedly over the course of many, many years, and it's cost me many gray hairs, and it's cost me much of my hair because I've torn it out of my head. They'll get numbers and they don't make sense. And the reason they don't make sense, oh, by the way, this was 39 degrees, right? The reason they don't make sense is because they didn't really double check their work. All right, what do we know from geometry? We know the biggest side has to be across from the biggest angle. We know that for sure. We know that the smallest side has to be across from the smallest angle, and that the medium side has to be across from the medium angle. So always double check that, because sometimes because of this rule, you'll get really weird values and they won't make sense. And all of a sudden, 15 will be across from a much smaller angle. Okay? So enough said with that. Now, I'm going to show you, because I know you'll love this, where does law of sines, while law of sines is a great law, it's a great rule, it's a great theorem, really, but it fails. It doesn't always work. All right, so remember what law of sines is. It says that the sine of angle A is to little a as the sine of angle B is to little b as the sine of angle C is to little c, right? All right, now notice what I need for this thing to work. Remember, I only use these guys pairwise, so I either use these two, or I use these two, or I use those two, right? In order for this thing to work, I've got 1, 2, 3, 4 variables. So I need to be able to solve for 3 of the variables. So what happens if I throw this triangle at you? Let's say I throw 12 and 6 and 6 and 4. Let's see if this is going to be. And 14. Yeah, that's right, right? Let's see. Oh, how can I check to make sure that I actually have a triangle? Remember the triangle inequality? Any two sides must add up to be a number greater than the third side, right? So 12 plus 6 is 18. That's greater than 14. 6 plus 14 is 20. It's greater than 12. And then what am I missing? Oh, yeah, 12 plus 14 is 26, which is clearly greater than 6. So I know I have a triangle here, right? But the problem is, if I try and solve for, let's call that A and B and C, do you see what happens? I'm screwed. Because, okay, I want to go sine A is to 6 as sine B. Oh, no, I've got 2 unknowns. I'm dead. That doesn't work. Another one, so this is failure number 1. Failure number 2 is, what if I have this situation? What if I have this written up? Let's say that side, sorry, I'm going to erase this real quick. Let's say that side B, this is actually good practice. Let's say side B is 10. Notice I keep things simple. Side C is, I don't know, 8. And angle A is 40 degrees. Okay? Now watch what happens here. All right, I have to do this the way that I do it or I'm screwed. All right, I'm going to make a 40-degree angle, comes off about there, and then I'm going to call this b equals 10. How you orient these things does not matter to me as long as you're consistent. And then I'm going to say, let's see, that looks like about 40 degrees right there. And that looks to be about 8. And then here, now you may say, oh, it's a right angle. No, it's not a right angle. This, by the way, is C equals 8, and then this is angle A. So this is angle B. Whoops, this is angle B. Whoa. Sorry, throwing my stylus around like I own the place. This is angle C, and this is side A. Now, this is the only angle that I have, which means I have to apply law of sines to that angle. So I have sine 40 degrees is to side A as, okay, now I got two sides to choose from, right? Ooh, except the angles across the triangle from them are unknown. Again, I'm screwed. I got 1, 2 unknowns. Well, that's not going to work. I can't solve for anything if I've got 2 unknowns. At least I can't solve for any real numbers. This is known as the side angle side fail. And this guy right here is known as the side fail. In other words, using law of sines, this should be law of sines, using law of sines, I cannot solve a triangle that has all 3 sides or side angle side. In other words, I've got a side, I've got an included angle. This guy right here is the included, right? Included angle. Wow, my stylus is giving me fits. That's the included angle. They both fail for that one. Okay? So that's how it works. All right. I'm going to go on now and I'm going to do what's called the ambiguous case. And it's nasty. This is probably one of the longer lectures of, I don't know, dare I say the entire semester really. Okay? Be patient. Take your time with this. We will work on it in class, I promise. I'm not just going to make you do this all by your lonesome, as it were, because the ambiguous case is really, really tricky. Okay, so go do me a favor. Ambiguous case. Get up, go for a walk, go to the bathroom, take a 15-minute break, and come back, and I'll see you when you get back, okay? Okay, see you soon.